At GCSE, you would have most likely encountered these three formulas: the length of an arc, the area of a sector, and the perimeter of an arc. Now, so far, you would have been using these in degrees, where you were given a degree and you were asked to find the length, the area, or perimeter of an arc or sector. But now that we're switching over into radians, these formulas are actually going to have to change a little bit. So right now they're in degrees, where we have theta as the degree angle, but we're now actually going to be moving into radians, and so we're going to actually have to change these formulas up a bit. So we're going to start off by finding the length of an arc in radians. So instead of degrees, we're going to try and change this into radians. So how can we do this? Well, firstly, we can start off by multiplying this equation out. So obviously we've separated it now, which you'll typically see it that way. We're actually going to multiply it out. So we can cancel the 2 out because there's a common denominator here. So we can just change this to 180 because 360 divided by 2 is 180. So we can change this to theta pi r over 180. Now, if you remember back a couple of videos, we found how to convert from degrees into radians. So currently this angle theta is still in degrees. And if you remember, to convert an angle from degrees into radians, we do theta times by pi over 180. And as you can see here, that's exactly what we've got. We've got pi over 180 times theta. So if we ignore the r for now, we can actually rewrite this angle in radians. So we can therefore write this as being theta r. We'll typically see it being written as r theta. So in this case, we've written it here as degrees, but then we've multiplied it by pi over 180. So now this angle, instead of being degrees, is radians. Okay, so that means that we can rewrite the length of an arc. Instead of the earlier equation we used, we can actually rewrite it as r theta. So the radius times the angle in radians, okay? So the next one we're going to try and find is the area. So the one we typically will use is area equals pi r squared times by theta over 360. So that's one you would have been introduced at GCSE. And we're going to do the same thing that we did last time and try and change it into radian mode from degrees. So currently this is in degrees and we're going to change it up into radians. So we're going to start off by multiplying this out. Now, unlike last time, we can't cross out a 2, unfortunately, but we can still multiply it out. So this is going to give us theta pi r squared over 360. Now, we can actually kind of rewrite this in a way, because what's another way we can write 360? Well, we can rewrite 360 as being 180 times 2. So we can actually rewrite this whole equation to be theta pi r squared over 180 times by 2. And if you want, we can also rewrite this as being theta pi over 180 times r squared over 2. So that's completely fine, we can do this. And like last time, we've got the exact same thing. Here the angle is in degrees. And if you remember, to convert an angle from degrees to radians, we multiply by pi over 180. So that's what we're going to do here. We're going to multiply this angle, which is in degrees, and change it to radians by multiplying by pi over 180. So this gives us theta times by r squared over 2, where theta has gone from degrees to now being in radians. And you'll typically see this equation being rewritten as a half r squared times by theta, where theta is in radians. And so thus we can rewrite our old area formula as being a half r squared times theta. The final one we're going to do is perimeter. Now, if you remember back to the perimeter, the only difference between perimeter and the length is that we're just adding the radius, aren't we? Because when we calculate the length of an arc, if we kind of look at an arc, when we used the length of an arc formula, we're only calculating this part, the kind of curved section. But when we calculate the perimeter, we not only calculate this, but we also calculate the side lengths here, the radii. And so that means that our current one is for perimeter is going to be the same one as the one for length, but a bit different. So it's going to be 2 pi r times by theta over 360 plus 2r. Now, if we ignore the 2r for now, this is the exact same thing as writing the length of an arc. So we can actually change this whole part into what we had here, which is r theta. So we can actually rewrite this whole thing as being r theta plus 2r, because this is just the length of an arc just in degrees. But here it's going to be in radians. So this is your final formula for perimeter. It's going to be r theta, where theta is in radians, plus 2 times the radius. And so therefore we have found our 3 formulas for the length, perimeter, and area of a sector or an arc. So we're just going to rewrite this as being r theta plus 2r. Now, it's super important that, number one, this only works when the angles are in radians, so they can't work in degrees. If you're given it in degrees, it's probably best to convert it into radians and then use the appropriate formula. And the other thing that's super important to mention is none of these formulas will be given to you on your formula sheet, so you're going to have to remember all 3 of these. But with time and practice, you'll get the hang of it and you'll be able to remember it. So yeah, thank you for watching my video.